This Thursday.
This Thursday.
Yeah. Yeah. So again, your homework sheet's got all the important dates on it. All the test dates. I like it.
Are you giving us the practice test today for Thursday?
Yes. No, I'm not going to give it to you because then some of you guys will just leave. I got to trick you into learning something. It's crazy.
And all the test corrections are due by the final?
At that point, whatever you haven't turned in yet is going to be due. I mean, anything you turn in after the final is, I'm not going to take it.
Yeah.
I love the name final. So if you leave the classroom, that's it. Whatever you put on my desk is all I'm taking. So it's got to be done at that time. I like, okay. Yeah.
So it might be a stupid question, but it's like my first semester. Since you're not on Canvas, where would we be able to find our grade for the class?
So on WebAdvisor, once I turn it in, they'll post it. You could always come see me in my office or email me. I always tell people on the day of the final, if you email me, I'll tell you how you did. I normally have it graded. In this case, I'm going to leave town the next day, so I'm going to have it graded that day. I think it's yours. I can't remember what day your final is. I'm leaving like on the 14th or something. Okay.
Is that going to include like anything we turn in the day of the final? Or?
Yeah. It's insane. I like my break to start quickly.
You're going to practice as bad as like on the test or in March?
So here's the interesting thing. The final is worth like 25% roughly. Remember I have like a shifting scale on that? So at the very end, whatever your lowest average is between your test average, quiz average, and final is going to count for 5% less. If you look at the syllabus, it's got a shifting percentage, right? Because I realized it's kind of arbitrary what I pick to a point, so I decided to make it shift and give you the highest grade. I know. You're welcome. Going into the final exam, you will have 75% of your grade determined. So the final exam is 1/3 as strong as that. So the final ends up affecting you less than you think. Your brain says, holy shit, it's the heaviest weighted thing. But at that point, you got 3 times as much of your grade set. Does that make sense? Now, I'm not saying just, screw the final. Because it can determine the difference between passing and failing. It can determine the difference between, B- or an A, right? Whatever you're shooting for. So it's important, but it doesn't hurt you as bad or help you as much as you might think, to be honest. And the last grade sheet summary I'll give you, I'll tell you if you make this on the final, you'll pass, you will get a B. Does that make sense? Okay. I like it. So yeah, I don't use Canvas. I hate it. Last semester, it was reporting incorrect grades. There's a beautiful reason why I don't use that shit. I want direct control over what my grades are, so if there's a mistake, it's me. All right? Sorry, I talked over something.
This coming quiz or the test, what chapters are they going to be covered? It's going to be chapter 8.
Yeah, so this test coming up will be chapter 8 through section 10.4, is it? Wait. Yeah, 10.4. Which actually is plenty.
Yeah.
It's all the absolute value stuff. There's the set stuff. Remember the union intersection stuff. There's the graphing inequality stuff. And then we got the radical stuff we've done so far. Okay. Speaking of which, let's get back into it. I've given all those out, but let me lay out the idea of this, the other side of the handout. I love this analogy. What can you do with this, for example? This is not what we're going to be doing, but this is a beautiful analogy. Can you divide 27 by 5 perfectly? No. If only it was a what up here? A little less. If only it was a freaking 25, right? So I can write this as 25 plus 2 over 5. I think I've shown you this once before as to why mixed number stuff works the way it does. Just in reverse. Then 25 divided by 5 I can do. So I do it. 2 divided by 5, no. It's not going to be a nice whole number, so I leave it. Is that cool? Nothing major there. I didn't do anything new. I just said it slightly differently because I really want you guys to see why this works. So help me out. What's the square root of 9? 3. What about the square root of 18? Can I do the square root of 18? Can somebody guess what it is? 18 is a little bigger than what number? That would be square rootable. 16. Square root of 16 is 4. So if I had to guess, I'd say like 4.1, 4.2, right? You guys with me? But there's something we can do a little bit better. We can do something very similar to this. Doesn't 18 have a number in it? Do you see how I did this with addition? Because this division is related to addition. Roots are related to multiplication. So what does 18 have in it that I can do the square root of?
9.
Yeah. Now watch, here's the step that's really critical. Here's the step you got to get down. The square root of 9 times 2 is equal to the square root of 9 times the square root of 2. As long as they have the same root, I can multiply them together, so I can do it opposite. What's happening to the 9? It's being taken the square root of. What's happening to the 2? It's being taken the square root of. So I can break them up. Just like I broke up 25 and 2. So it's like there's 2 extra in this 27. Here there's a factor of 2 extra. So what's the square root of 9? 3. What's the square root of 2? I don't freaking know. There. So it's very similar to this. I can do the part of 18 that I can do, and I can leave the part of 18 that I can't do. It's just like what we do up here. This is a mixed number, and so is this, isn't it? There's a whole part, and there's a radical part. It's a mixed number, much like this one. So watch this. Let's see. What about square root of 50? What part of 50 can I do? 25, 11. So how do I rewrite that? And I could write this as square root of 5 times 10, right? Isn't that true? But can I do square root of 5 or square root of 10? No. So that's a silly way to do it. So I'd rather do square root of 25 times 2. Yeah. And then you do the parts you can, and you don't do the part you can't. It makes almost too much sense. Okay, I like it. What about cube root of 24? Now you got to think about cube numbers. What are some cube numbers?
8.
8's a cube number. Does it go into 24?
Yes.
Yes, kick ass. Because I want to break 24 up into a factor that I can do the root of it times whatever the hell else trash is in there, right? That's messing me up. Stupid 24. But there's a part of it I could do. So I'm going to pull that part out. 24 is 8 times 3. So that's cube root of 8 times cube root of 3. What's the cube root of 8? 2. What's the cube root of 3? I don't freaking know. Third base. Maybe. So just to show you kind of the other way around on this idea, if I have the square root of 2 times the square root of 6, I can't do anything with either of those separately. Do you guys see that? Because 6 is 2 times 3. I can't square root either. But what is the square root of 2 times the square root of 6? It's the square root of
2 times 3.
Which is
12.
right? Let's see why that's true. Don't just accept it. What's 2 times 6? 12. Why am I able to multiply those together? Because they both have the same root, namely none. Neither one of them are rooted. As long as they have the same root, I'm allowed to multiply them. Why? Don't just take my word for it. How do I rewrite square root of 2 in fractional powers?
2 over 1.
2 to the 1/2. 6 to the, can't I take a 1/2 power out? Undistribute it? And what's 2 times 6? Which is square root of 12. So if they each have a square root, I can make one big ass square root over the whole thing. Now, what can I do with the square root of 12? Yeah, square root of 12 is square root of 4 times square root of 3. Square root of 4 is 2. Square root of 3 is, I don't know. I like it. So again, the more you are comfortable with numbers themselves, the easier a lot of this stuff is. If you can't break 12 up to 4 and 3, which most of us should be able to, right? That's a problem. What about something not as obvious? What about square root of 96? Let me show you a different method, and you can pick whichever method you like. If it's a freaky-ass number, I'm not sure what the hell. You could either just start dividing it by squares. That's fine. Divided by 4, divided by 16, divided by 9. I skipped 9 for some reason. Here's another way you could do this. What is the square root looking for inside of it? Why can't I do the square root of 5? But I can do the square root of 25. Why? What's 25 got? 2 5s. Square root is looking for groups of 2. Do you guys get me? So cube root's looking for groups of 3. It's crazy, because I want to cut it in third, and there's not a group of 3, I can't cut it in thirds. This one, square root, so if I break it up, start factoring 96. 96 is 2 times, 2 times, or you want to do 3 times? Sure, we can do that. 96 is 3 times 32. And 32 is, say again? 32 is 8 times 4. I like it. Sorry, Adrian, I think you said that. I missed you. 8 is 2 times 2 times 2. 4 is 2 times 2. Do I see 2 anythings? I see 2 2s and another 2 2s. 2 2. What is 2 times 2 times 2 times 2? 16. So I could actually take this and I could use it. 16 times what's left? 6. What's the square root of 16? 4. What's the square root of 6? I don't know. Another way to do this is, for every group of 2 things I see, one of them comes out. That's what a square root does. Square root of 9 is 3, because 9 is 3 times 3. So one of them comes out. So what would happen here? A 2 would come out, another 2 would come out, and then the 2 and the 3 are left inside. 2 times 2 is 4. Wow. Same answer. So let me give you a handout that's got both of these methods. Oh, no, I already did. So if you look at the back of that, yeah, it's got both of those methods there. You could do it either way that makes more sense. If neither way makes sense, this sucks. You've got to get some help. So I want you to go ahead and try the problems out on that sheet. It's on the reverse of the one I just gave the answer key out for. If you don't have a sheet, you're going to want to get with somebody else, because I have given all mine away.